In this example, we need to write an inequality that states the domain and range of the graphs. The domain, that's the possible x's, and the range is the possible y's. If we look at this first graph, it appears that x could be, well, just about anything. We want to see for what values is the function defined, or at least where does it exist. So at -1 the function exists. This point is on the graph. -2, -3, -3.5, -4. Actually, any value on the number line will be a part of this graph. So the domain will be from -infinity to infinity. Any real number fits in between these two values, and that's what we want. The range is similar. So here the range, or the value of y is 1, 2, 3, 4, 5, and every value in the middle of those would work. Same thing here. This graph continues down to -infinity. We always want to write the lower number on the left-hand side. And then these are the values of y, or the outputs. The next graph looks like it has the same domain as the first one. As we go left, this end keeps on going, and this end keeps on going. So any value of x will work. 1 has an output, 2 has an output, 3 has an output, 4 has an output, and all the numbers in the middle. So the domain for this one will be -infinity is less than x is less than infinity. The y values, though, go down to this minimum and then come back up. So nowhere below -4 does this graph exist. That's the lowest it will be. It could be equal to that, though, so we want to include that point. And then we can go to infinity as either end of the graph goes to infinity. The domain for this one, we want to go to the leftmost value of x and the rightmost. The graph doesn't exist with left or right of these values, and so we need to state that as an inequality. X could be in between -5 and 5. The range is similar. The range is from here to here. Nowhere does the graph exist outside of those values, and it looks like that's -5 less than or equal to y is less than or equal to 5.